Good morning, dear students. My name is Ferhan Mazher, and today is 13th of October 2021. The day is Wednesday, and right now I am with the 9th Cambridge class, and the subject we are studying is D Maths 4024. It's Cambridge O-Level Mathematics, and we are working on the syllabus, and we are working on the D3, the new syllabus Mathematics 3, and that's the 7th edition we are using, and we are working on it on the chapter number 6, and we are working on the review exercise 6. So let's start. And today in this session we are going to do question number 8. We will start from the question number 8. We will do question number 8, 9, 10, and 11. So let's start today's video. So we will go to the question number 8. Okay, here we go. So on your screen, you can see the question number 8 is showing up. And let me read the question for you. The question number 8. So the question number 8 from the review exercise 6. Here, this diagram is given, which I have also shown here. This diagram, this is also given in the question. Find the diagram shows the point A, whose coordinates are -1, 0, and the point B, whose coordinates are 0, 3. First part is find the equation of the line passing through the A and B. That's the first part. You know, the 2 points are given, A and B, their coordinates are given, and we want to find out their equation. The process is very simple. You see the process we have already learned, that the process is that you first of all find the gradient of the A and B, and the formula is y2 minus y1 divided by x2 minus x1. The 2 points are given, their coordinates are given. We can very easily find out their equation, their gradient. And then we will find the equation by using this formula, y minus y1 equals to m bracket x minus x1. Okay, so here you can see that in the first part, we have tried to find out the gradient of the m. So y2 minus y1, that will be 3 minus 0, divided by x2 minus x1, that will be 0 minus minus 1, which will make it 0 plus 1. So the gradient is 3 divided by 1, which means 3. So once I know the gradient, and I will use one of these points, and I will use this equation, y minus y1 equals to m bracket x minus x1, to find the equation. So I'm going to use this B point, and y minus 3 equals to m is 3, and x minus x1 is 0. So it will be y minus 3 equals to 3x, y equals to 3x. This minus 3, when it go to the other side, it will become plus 3. So the equation of this line AB is y equals to 3x plus 3. So that is the first part. The second part is, given that the length of the AB is under root h in units, find the value of the h. So it is given that the length of the AB is equals to the under root h, and they want you to find out the value of the h. So I will apply the formula of the length and the distance formula. You remember the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square and a square root on top of that. And that will be equals to under root h. So here you can see I put the values in that formula. So it will be 0 minus minus 1, it will make it plus 1, 0 plus 1 whole square, plus 3, y2 is 3, so y1 is 0, 3 minus 0 whole square, and under root over it. So it will be 1, 1 square will be 1, it will be 3, 3 square will be 9, 9 plus 1 is 10. So you can see that under root 10 is equals to under root h, so it means the h value is 10. So we have the value of the h, and that is 10. And there is another point in the question number 2. He says, given that the length of the AB is under root h units, find the value of the h. Then he says, the point minus 5 comma k lies on the BA produced. So the minus 5 comma k, so this is the line AB, And this line also has a point whose coordinates are -5, k, because this point is on this line, so it will satisfy this equation, the equation of the AB. So because it will satisfy its equation, so in the place of x, I will put -5, and in the place of y, I will put k into the equation of the AB. So here we have the equation of the AB, and you can see in the place of y, we have substituted k, and in the place of x, we have substituted -5. So k will be equals to -15 plus 3. So k will be equals to -12. So this is the whole part 2. Then we have the third part. He says, third part is find the value of the k. We are done with that. He says, fourth part, given that y equals to x plus 1 is the line of symmetry of the triangle ABC, find the coordinates of C. So he has given us that there is a triangle, its name is ABC, and the line of symmetry of that triangle is y equals to x plus 1. So you can see that what I did here, whenever this line of symmetry questions come in your paper, you draw a grid and you plot all your points here. So the line of symmetry is y is equals to x plus 1. So I made a table, so I can draw this line on the grid. So I put x0, x1, x3, x equals to 4, and I found the values of the y. In this value, in this equation, we substituted the x with the 0. I get 1. When the x is 1, the y is 2. When x is 3, y is oops, I wrote this number wrong. It is supposed to be 4. And when I put 4 here, it is 5. Okay. So what we will do, we will plot these points. This number I wrote here 3, it is supposed to be 4. Okay. So at 0, it is 1. At 2, at 1, it is 2. At 2, it is supposed to be 3. So I think I made a mistake here. So if this is 2, then this is 3. Okay. So at 4, it is 5. So just join these points. So this will be the line of symmetry. This will be the line of symmetry. So this A point and B point are already there, and they have told us that this there's a triangle ABC. You can see this point A is on the line of symmetry, so it will not have the image. We cannot make it image because it is on the line of symmetry. So, and the point B, it is not on the line of symmetry, so its image can be formed. So from B, you come perpendicularly to the line of symmetry. And remember my words, I'm saying from B point come perpendicularly, means the line coming from the B should make 90-degree angle with this line of symmetry. And whatever is the distance, this distance, same distance you go below this line of symmetry in the same direction. This should be perpendicular to the line of symmetry, okay? So the distance here, this distance, same distance should be here, and you will find the point C. So this is done graphically. So the coordinates of the C will be 2, 1. So remember, this is 2. This is not 3. This number here, it is supposed to be, I have a pencil here. So this number is supposed to be 2. Okay. So this number is supposed to be 2. So I think that you will be okay. So I think you understand this question, and let's go to the key. And okay, so that was the question number 8. So let's move to the next question, and the next question coming up on your screen is question number 9. So let me read the question number 9 from the book. He says, the equation of a straight line L1 is 5y plus 12x minus 60 equals to 0. It cuts the x-axis at P and the y-axis at Q. The first part of the question is write down the coordinates of P and of the Q. You see, this is the equation of the line number 1, 5y plus 12x minus 60 equals to 0. So when it will cut the x-axis, the y will be 100% 0. Any graph, when it cuts the x-axis, the y coordinate at that point is 0. So we, in this equation, in the place of y, I will put 0. So here you can see we have substituted the y with 0. 5 into 0 plus 12x minus 60 equals 0. So 5 zeros are 0, so it's gone. 12x is equals to this minus 60, go to the other side, become plus 60. So x will be equals to 60 by 12, so x will be equals to 5. So the coordinates of the point P where the graph cuts the x-axis will be 5, 0. Then when it cuts the y-axis, the x will be 0. So in the original equation, 5y plus 12, in the place of x, I will substitute 0. So we will have 5y plus 12 into 0 minus 60 equals 0. 5y minus 60 equals 0. 12 zeros are 0. So 5y is equals to 60. So y is equal to 60 divided by 5. So y is equals to 12. So the coordinates of the point Q will be 0, 12. So this is the first part of the question number 9. In the second part of the question number 9, he says, find the length of the PQ. The second part is very simple. He wants you to find out the length of the PQ. In the first part, we just found the coordinates of the point P and the point Q. And now they want you to find the length PQ. The formula for the length, you know, the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square and under root over it. So just use these 2 points. So it will be 0 minus 5 whole square plus 12 minus 0 whole square. So 5 square will be 25, 12 square will be 144, and 25 plus 144 is 169. And when you take square root of it, that gives you 13. So the length of the PQ will be 13 unit. So that was the question number 9 and its second part. Then he says another line L2 has the same gradient as the L1. So it means L2 and L1 are parallel to each other. They will have the same gradient. And passes through the point 0, minus 2. Another thing about the line number 2, that it is passing from the point 0, minus 2. Here I have tried to show you with the help of a diagram so that you can understand that. Means you can perceive that what's the meaning of those sentences. L2 is parallel to the L1 because they have the same gradient, and the L2 is also passing through the 0, minus 2. So the gradient of the, first of all, let me find what is the gradient of the line number 1. The equation of the line number 1 is 5y equals to, I will take that 12x and minus 60 to the other side. So you will have 5y equals to minus 2x plus 60. This 5, which is multiplied with the y, it will go to the other side and it will divide there, and it will divide with both the terms. So you will have y equals to minus 2 divided by 5 and plus 60 by 5. So the gradient when the y, you know, when the y is alone on one side, the coefficient of the x on the other side, that represents the gradient. So the gradient of the line number 1 is minus 2 by 5. Minus 2 by 5 will be the gradient. Now, because it is given that both these line number 1 and the line number 2, they both have the same gradient. So the M2 will be equals to M1. It means that the value of the M2 will be minus 2 by 5. Now, the question is find the equation of the line number 2. I know a point on the line number 2, its coordinates are 0, minus 2, and I know the gradient of the line number 2, that's minus 2 by 5. So I can find the equation of the line number 2. The formula is y minus y1 equals to m bracket x minus x1. So I will substitute this number, these coordinates. In the place of x, I will put 0. In the place of y1, I will put minus 2. And in the place of m, I will put minus 2 by 5. So here you can see we substituted those values. Y minus 2 will be plus 2 equals to m is minus 2 by 5 bracket x minus x1 is 0. So this 5 which is dividing here will come to this side and it will multiply both these terms. 5y plus 10 is equals to minus 2x. 5y is equals to minus 2x minus 10. This plus 10 went to the other side. So this 5 is multiplying with the y, it will go on the other side, it will divide. So you will have y equals to minus 2 by 5x minus 10 by 5. So you will have y equals to minus 2 by 5x minus 2. So you see how we have found the equation of the line number 2. Hopefully you understand it. That's how we worked on the line number 2 to find its equation. The fourth part is, he says, given that the y-axis is the line of symmetry of the triangle PQR, find the coordinates of the R. You know, the P and the Q point, they are already on the graph. We know their coordinates. So I draw a grid here. I plotted the point Q 0, 12, and the point P, which is 5, 0. You can see I plotted it here. And the y-axis is the line of symmetry. So this is your line of symmetry. You can see that the Q is on the line of symmetry. So it's an invariant point because it's on the line of symmetry. We will not have its image. The P point will have image because it's 5 units to the right side of the y-axis. And I will move it perpendicularly. Perpendicularly means that this point should be joined with the line of symmetry. Thus, angle here should be 90. So it's 90. So if it's 5 steps this way, its image will be 5 steps to the opposite side. So R will be the image of the P. So its coordinates should be minus 5, 0. The coordinates of the R will be minus 5, 0. So we have found the R point. So you can see this is the line of symmetry, and this is the triangle PQR. This is the peak of the concept of this. These are the peak questions of on this concept. So that was, my dear students, question number 5. Question number 9 from the review exercise 6. And I hope that you have understood this. Okay, so let's move to the next question. So on your screen, the question number 10 is showing up from the review exercise 6 from the book 3, D3. This is New Syllabus Mathematics 7th edition. Question number 10. The diagram, this diagram is also given in the question. He says the diagram shows a trapezium ABCD, in which the AB is parallel to the DC. It's already given to us that the AB and the DC, they both are parallel to each other. He says AB is parallel to DC, and the area of the ABCD is 84 units square. The area of this trapezium is already given to us. It's 84. So given that the vertices of the A are minus h, k, the B is 11, 6, C is t, 0, and the D is minus 2, 0. Find an expression for the T in terms of age. Okay, so let me show you. It's a little tricky question. It is given that the AB side and the DC side, they are parallel to each other. The AB side and the DC side, they are parallel to each other. And it is also given to us that that the DC, I can tell you that is a horizontal line. How do I know it's a horizontal line? Because you see the C, the Y coordinate is 0, the D, the Y coordinate is 0. So both these points, the Y coordinate is 0, and obviously this line will be horizontal because they have the same value of the Y in their coordinates. So they will be horizontal. They will make a horizontal line. And any line which is horizontal, its gradient will be 0. So AB is parallel to DC. So I know that the M of the DC will be 0. Here you can see I have shown by the process that the gradient is 0, y2 minus y1 divided by x2 minus x1. 0 minus 0 divided by t minus 2, that will be t plus 2. So 0 by t plus 2, that will be 0. So the gradient of the DC is 0. Here mathematically I have shown why it is 0. Or conceptually I know that if the DC line is horizontal, then its gradient will be 0. Because the AB line and the DC line, they both are parallel to each other. It is given in the question statement. So the AB will have the same gradient as that of the DC. So the AB gradient will be also 0. So if this AB line, it has gradient 0, it means that this line is horizontal. So whatever is the value coordinate of the Y in the B, Same will be the y coordinate in the A. So here the y coordinate is 6. So here the A should also have the y coordinate 6 because the AB is a horizontal line. So the K value will be 6. So now I know the K value. Another thing which is given in the question is that the area of the trapezium is 84. You know, this trapezium, its area is 84. So now I know the K value. I can apply the formula to find the length of the AB. The length of the AB will be 11 minus h whole square plus 6, and the K value is also 6. 6 minus 6 whole square and under root over it. So it will be 11 plus h whole square. This will be 0. 0 square is 0. So this square and square root will be cancelled. So AB is equals to 11 plus h. So I know that the length of the AB will be 11 plus h. The length of the DC will be the same formula, x2 minus x1 whole square plus y2 minus y1 whole square. So you can see here t minus 2, it will be t plus 2 whole square plus 0 minus 0 whole square. So t plus 2 whole square and under root over it. So square and the under root will be cancelled. So DC is equals to t plus 2. You know that the area of the trapezium is 1 by 2 into height into sum of parallel sides. 1 by 2 into height into sum of parallel sides. So these two are the parallel sides and this is the height. Now I know the height. How do I know the height? You see here the y value is 0 and here the y value is 6. So this vertical height will be 6. So here you can see I know the area is 84. 1 by 2 into height is 6 into A value, that this value, this is 11 plus h, and plus this value, that is t plus 2. So this 2 will go to the other side. It will become 168 equals to 6 into 2 plus 11, 13 plus h plus t. So 168, this 6 will multiply with this bracket. So you will have 168 equals to 78 plus 6h plus 6t. So this 78 will go to the other side. It will subtract. So you will have 168 minus 78 equals to 6h plus 6t. So 168 minus 78 will be 90. So equals to, I have taken 6 common. Then this 6 will go on the other side. It will divide with the 90. So you have h plus t equals to 90 divided by 6. So h plus t is equals to 15. Now this, I want the t in the terms of h. So I will take h to the other side. So you will have t equals to 15 minus h. So this is how you will find the t in terms of h, an expression for the t in the terms of h. So this question is not that easy. I think it is the height of its this concept, coordinate geometry. So my dear students, this was the question number 12. Okay, so we are done with that, and hopefully you understand this. Let's move to the next question. The next question coming up on your screen is question number 11. And let me read it from the book. It says, the diagram C. In the diagram, C is the point 0, minus 4, and A is a point on the y-axis. The line AB meets the horizontal line through C at B. Okay, so this is given to me that this BC line is horizontal. So whatever is the y value in the C, same will be the y value in the B. So coordinate of the first question is write down the coordinate of the line passing through the BC. So BC line is basically a horizontal line. And we have already learned in our previous lessons that the horizontal lines, any horizontal line, its coordinate is y equals to a constant. Here the y value on that line, every point will have y equals to minus 4. So the coordinate of the horizontal line will be y equals to minus 4. So very easily I can give the coordinate of the y of the BC because it's a horizontal line. And so y equals to minus 4 is the coordinate of the BC line. Then the question is, given that the coordinate of the line passing through the A and B is 2y minus 5x equals to 4, find the area of the triangle ABC. Okay. So it is given to me the coordinate of the AB line. This line, I know it's a coordinate. I know the equation of this line AB, that is equals to 2y minus 5x plus equals to 4, sorry. And that is given in the question. Now I can find the coordinates of the B. I know the y value here is minus 4, but I don't know what's the value of the x. So in the AB, because this point B is on the line AB, so in this equation of the AB, I will put y equals to minus 4 because the B has y coordinate equals to minus 4. So here you can see that I have substituted that value, and y 2 into minus 4 minus 5x equals to 4, minus 8 minus 5x equals to 4, minus 5x equals to 4 plus 8, minus 5x equals to 12, x equals to 12 divided by minus 5. So 12 divided by minus 5 is minus 2.4. So the coordinates of the point B are minus 2.4 comma minus 4. In the same way, I can very easily find out the coordinates of the A point because A is on the line AB. Its equation is this. And I know that because it's on the y-axis, the x here is 0. So in the original equation of the AB, in the place of x, I will substitute 0. So 2y minus 5 into 0 equals to 4. So 5 zeros are 0. So 2y is equals to 4. Y is equals to 4 divided by 2. So y equals to 2. So the point A will be 0, 2. The coordinates of the point A are 0, 2. Now you can see this is that triangle which is made on that grid. The point A's coordinates are 0, 2. The point B is minus 2.4, minus 4. And the point C is 0, minus 4. So it's a vertical line. And this side, you can see both of them, the x is 0, the y here is minus 4, and the y here is 2. So this line is actually 6. Very easily you can tell this. Because the y value here is minus 4 and the y value here is 2. So this length is 6. Here it's a horizontal line and they both have the same y. So this length will be from 0 to minus 2.4. So this length is 2.4 basically. So in this triangle, in this triangle, we know the height and the base of this triangle. So very easily I can find the area of this triangle. The area of the triangle ABC will be 1 by 2 into base into height, 1 by 2 into 2.4 into 6. So that will be 7.2 units square. So the area of the triangle, you can see very easily we can find. The third part is given that the length of the AB is under root L units. Find the value of the L. So it is given that the length AB is equals to under root L. The length AB, I know the coordinates of A and the B. These are the coordinates. I will apply the distance formula on A and B and I will make it equals to under root L. So it will be 0 minus 2.4. That will be 0 plus 2.4 whole square. Plus 2 minus plus 4 whole square under root over it. So it will be 2.4 whole square plus 6 whole square equals to under root L. So just do this calculation. It will be 612 under root over it equals to under root L. So it means the L is 612. So the value of the L will be 612 actually. So if you take the under root actually, so this AB length will be 24.74. If you take the under root of the 612, the value of the, the value of the L will be, the length AB will be 24.74. So we know the value of the L. That was the third part. The fourth part is find the length of the perpendicular from the C onto AB. So the trick is this. You can see I have drawn that triangle here, ABC. I already know the area of this triangle. I already know that the area of this triangle is 7.2. So this AB side is 24.74 and I want the perpendicular from C onto the AB. I already know the area of this triangle, that's 7.2. So suppose this is that perpendicular coming from C onto the AB. So I will take this side as the base and then this will be the height. So I'm calling it the perpendiculars. This side I'm calling it P, perpendicular. So 1 by 2 into the base into the height. And we already know that that is 7.2. So if I will make the P alone, 7.2 multiplied 2 divided by 24.74. and that will be 0.58. So the p value is 0.58. So once you know that, then their question is, what is the his question? Let me read the question, and that is the fifth part. He says, given that the coordinates of the D are 2.4, 2, show that the ABCD is a parallelogram. So here he has given us a point D whose coordinates are 2.4, 2. So here on a rough grid, I have drawn the 4 points and joined them. A is 0, 2, B is minus 2.4, minus 4, C is 0, minus 4, and the D point is 2.4, 2. So when you join them, it looks like a parallelogram, but we have to prove that this is a parallelogram. So how you will prove that this is a parallelogram? The methodology is very simple. You will, in the parallelogram, you know, the opposite sides have the same gradient. So I will find the gradient of the AD and the BC, and they will be equal. And then I will find the gradient of the CD and the BA, and they will be also equal to each other. So we will have a quadrilateral whose opposite sides have the same gradient. So this will be a parallelogram. This is how I will prove it. So find the gradient of the AD, that will be 2 minus 2 divided by 2.4 minus 0, and that will be, the whole thing will become 0 because on the top 2 minus 2 is 0. In the same way, find the gradient of the BC, it will be minus 4, y2 minus y1 divided by x2 minus x1. It will be minus 4 minus minus 4, that will make minus 4 plus 4, divided by 0 minus minus 2.4, that will make 0 plus 2.4. So on the top you will have 0 divided by 2.4, and that will be 0. So you can see that the gradient of the AD and the gradient of the BC, both the gradients are 0, so they are parallel to each other. Okay. Now find the gradient of the CD, and that will be 2 minus minus 4, that will make it 2 plus 4, divided by 2.4 minus 0, and it will give you 6 divided by 2.4, and that will be 2.5. So the gradient of the CD line is 2.5. In the same way, I will find the gradient of the BA, and that will be 2 minus minus 4 divided by 0 minus minus 2.4. y2 minus y1 divided by x2 minus x1, the way we find the gradient. So it will be 2 plus 4 will be 6, and downstairs 0 plus 2.4 will be 2.4. So it will be 6 divided by 2.4, and that will be 2.5. So you can see that the gradient of the CD and the gradient of the BA is equals to each other. So in this diagram, the opposite sides have the same gradient. So the opposite sides are parallel to each other. So in a quadrilateral four-sided figure, if the opposite sides are parallel to each other, then that figure is a parallelogram. So my dear student, that was question number 11. And by completing this question, we have reached the end of this. So let me tell you one thing very important, that this session is over. And in this session, we have done question number 8, 9, 10, and 11 from the review exercise 6 of the new syllabus mathematics, third book, chapter number 6. It's the review exercise. The name of the chapter is coordinate geometry. The subject we are studying is D Maths 4024. So my dear students, if you find this video helpful to you, do me a favor. Don't forget to like this video, and don't forget to subscribe to my YouTube channel. And because when you like my video and you subscribe to my YouTube channel, it's a beneficial thing for me. It's an appreciation for me, and it's a fuel for me, and I get energy from it. So if you like this video, and if you have learned something from this, or you have learned something about the coordinate geometry, and you are able to do the questions now, share this video on your Facebook accounts and on your Instagram, or so that your friends can also watch this video. So thank you very much, my dear students. It was a great pleasure for me to teach you online. So thank you very much, everybody. Have a good day and God bless you all. Bye-bye.